So hi there, I'm Parik Goswami. I'm Professor of Technical Textiles. I'm Head of the Department of Fashion and Textiles and also Director of Technical Textile Research Center at University of Huddersfield. Thank you very much.
Well, it's great to see you. Thank you. And we're very pleased to have Parik because he seems to know everybody in this world of textiles and innovation in Kirklees and Huddersfield. We've also got Fiona. I'll unmute you, Fiona. So can you explain about who you are, Fiona?
Yes, hi everyone. I'm Fiona and I am the editor for the Technical Textiles channel at World Textile Information Network, and we're an information provider based in Leeds.
Great, well, it's great to have you, Fiona. And Archie, would you like to explain where you're from and why you're here? To unmute yourself. Try again, there we go. Oh. There.
Okay. Hello, my name is Sahar. I am a research fellow at the School of Design at Leeds University. I work with Professor Ning Tao Mao on haptics technology and on tactile of the fabrics.
Great, thank you. I've called you Archie, actually. Your name's Sahar. I'm so sorry. I was reading the thing on the thing. So David should be joining us, and I'm sure he'll be here very soon. So guys, if you'd like to, in fact, Fiona and Sahar, why don't you stop your videos? And Parik, you leave yours on because we're going to hear from you first. Great. So I'm just going to read out a few more people where they're from. We've got Ali from Huddersfield, University of Huddersfield. We've got Judella from Swindon. Rathin, hello from Bangladesh. Wow, brilliant. Lovely to see you here. We've got Francesca from Huddersfield, Rebecca from Bradford, Esther from Catalonia and Barcelona. Wow. Here's David. Nice to see you, David. I'm so pleased you were able to join us. Technology is a tricky business. You just need to unmute yourself so you can say hello. Hello.
Good afternoon, guys.
Hi, David.
Just explain where you're from and what, just very briefly to say hello.
Hi, my name is David Buxton and I'm working for a company called Roaches International. My position is Sales Director and we're based just outside Leeds in a place called Birstall.
Great. Well, we're going to be hearing from David after Sahar, and they're involved with a very similar project, so that's a great link up we've got there. So David, if you'd just like to stop your video and we'll come to you later on, if that's all right. Nice to see you.
Absolutely. Thank you so much. So basically, firstly, thank you everybody for coming. Thank you, Tom, for arranging this, and Kirklees Council. Some of you joined later, so I'll repeat who I am. I'm Professor Parik Goswami. I'm Professor of Technical Textiles, and I'm Head of the Department for Fashion and Textiles and Director of Technical Textiles Research Center at University of Huddersfield. Now, I can't really congratulate you more on the timing to arrange this session now. Now, what I did today is, as I only have 10 minutes, I decided not to do any presentation, just take the opportunity to just discuss my feeling with the audience. I really think for the textile industry and the fashion industry, we never saw a more exciting time than where we are now. It is challenging, nevertheless, it's exciting as well, because there are huge amount of possibilities coming our way. Some are driven through policy networks, I'll name a few. Some where now the governments are realizing how important role textile plays in our life. You probably don't even realize sometimes that the car you're driving, you can drive them because textiles are there in the engine somewhere. It is in your aeroplane. It is in your house, everywhere. It is used in construction. I'll give you one example, right? Recently, Indian government announced $1.4 trillion to improve their infrastructure. And they already accepted the fact that textile will play the biggest role in their infrastructure development. So that means we need to rethink about the industry. We need to understand what to do, how to do, and how to bring things together. Now, there are so many aspects of textiles, right? It's very difficult to cover every aspect, but some of you might be surprised to know that textile is actually used as implantable material as well. So you can actually use textiles for heart tissue repair, for your bone replacement and stuff like that. Now let's stick with that point, right? Now, if I want to do some research on medical textiles, I can't do it alone because I am a textile expert. I need somebody who is a biology expert. I need somebody who understands the physiological aspect of that research. So basically, where I'm going with it is, textile research now have become more interdisciplinary than it has ever been. And therefore, we have to bring people together to do that meaningfully. It's a teamwork. And that is why this initiative by Kirklees Council is so exciting, because it is bringing different people together. Means if I look at the lineup for today, we have Fiona, who is from a publishing house, who they gathered intelligence and spread that intelligence out. We have Sahara, who is from University of Leeds. We have David, who is from the industry. And you know what? We all knew each other before even this one. Why? Because we work together. And we have created that culture that we can work together, and that is the most exciting bit. What are the problems to solve? There are huge amount of opportunities and challenges coming to the textile industry in the next 10 or 20 years. To start with, there are new directives like single-use plastic directive in the Europe. UK got its own aspirations, like you must have heard about the UK plastic pack. Textile is not part of it, but we are also an industry that depends on polymer. So we have to understand how to recycle, reuse, or biodegrade every textile component that we use. We are not prepared for that yet, but that means research-wise, we have to do a lot of different things. So we need to bring everybody together. It is not only I'm talking about the industry and the research organizations, because we are already working together, but we have initiatives where the government bodies are directly involved in that. We are working with LEP, the Leeds Enterprise Partnership. We are working with Northern Powerhouse and the civic society like that. So we have created an ecosystem where we feel in Kirklees and in the wider Leeds region, we are actually totally geared to face that challenge for the industry together. And that is why this is important. We want to show the collective strength that we got in this region. To give you a tangible example, there are others as well, but I want to give an example where I am a part of. I am a co-investigator in that project, which is called the Future Fashion Factory. Now, this is a consortium between 3 universities, University of Huddersfield, Royal College of Art, and University of Leeds. We have 3 universities. We have LEP involved in that, and we have, well, I have my colleague here, Sue can give the exact number, but I think we have 220 companies involved in that particular project. What that means is we are happy to look outside the immediate boundary of our institutions, and we want to collectively increase our strength for the betterment of the industry, for the people living in the world. And we are looking at the circularity, we are looking at the sustainability of the industry, and we are ready to face future challenges. What can be that challenge, right? One, we know due to COVID, we know that now we are using face masks. One point is how to get those face masks. Is the supply chain ready for that or not? We are working on that, but we are also thinking ahead. We are thinking when that billions of face masks are absolutely thrown away into our marine system. What happens then? How to recycle medical waste, how to understand what to do with those face masks. So guys, I'll not take too much of time, but I want to say that our industry is ready for that. Our industry wants to work collaboratively so that we can work for our future generation. We are sustainable, and there is huge amount of opportunities for textile industry. It is not a legacy industry. This is an industry for the future. So please contact us, contact my colleagues in Leeds, contact me in Huddersfield, contact the industries here, contact the Future Fashion Factory team. Please try to find out what are the real opportunities in textiles, how the textile industry together we can grow, why textile is the future. That is it from me. Thank you very much.
Thank you very much, Parik. That was lovely. I mean, I wanted to ask you, as you was talking, what is it particularly about this area, about Kirklees and the North Yorkshire area? Well, not North Yorkshire, the North and Yorkshire. What is it particularly about this area that you think is very exciting?
Well, to start with, right, the biggest supplier to the industry, the wool fiber, is located in Bradford. Some of the biggest textile association like SDC, where I'm a trustee of as well, and we have the next president of SDC from India, Dr. Mr. Ullas Nimkar in our audience today. I have seen that. Now that infrastructure is already there. One of the biggest universities for textile education in the world is in this region. The industry exists in this region. So the infrastructure is there. The willingness is there. The academic support is there. And that is the key of this region, that we have the infrastructure already.
And you're a great advertisement for this whole industry in this area, Parik, and your enthusiasm really shines through. So it's so good to have you first to sort of set the context of all this stuff. It's fantastic. Now, if anyone's got any particular comments for Parik, please store them up and put them in the chat. And then after everyone's spoken, we can get more of a conversation going. Okay. So Parik, I'm going to say thank you to you. If we could, we'd give you a round of applause. But yes, well done. Thank you. And Hassan, you were a great sort of supporter of Parik. But I'm going to say maybe if we put both of you on stop your videos, and we're going to hear from Fiona next. So Fiona, can we see you again? Let's have Fiona popping back on. Great. Hello, Fiona. Now what I'm going to do is share my screen, which has got the PowerPoint on. Just in case, I'll ask you to unmute, Fiona, so we can hear from you as well.
Oh, yeah.
All right, so I'll just share the screen. This takes a couple of seconds. And Fiona, you're going to be talking about particular innovations that you're part of. Let's check this works. Okay. Right, so can everyone see that? I think you should be able to see that screen. So I'm going to spotlight Fiona. And now we're going to pass over to you, Fiona. As ever, please ask questions, make comments, put them in the chat, and we'll come to them after Fiona's 10 minutes. Okay, over to you, Fiona.
That's great. Hi, everyone. And as Parik was saying, thank you to the organisers of Woven Go and See for inviting me to participate in this event. And as you can see there, just to reiterate, I'm the team leader and editor of technical textiles at World Textile Information Network. And it's great that this is an innovation special because the company I represent is centred around all things innovation in the textile and apparel industry, spanning technology, materials, and business strategies. So I just wanted to spend 10 minutes telling you about who we are, what we do, including the services we offer. And then I thought I'd round off the presentation by highlighting a few recent innovations we've reported on within the emerging field of smart textiles. So if we could just move to the next slide, please, Tom, thank you. So yes, we are an information provider based in Leeds, And our main purpose is to offer intelligence and insight into the global textile and apparel industry. So we adopt a business-to-business model. And we cater for all players in the value chain, from educators and associations to technology OEMs, chemical and fibre producers, manufacturers and brands and retailers. And some of our high profile clients include Puma, Microsoft, Apple and Hugo Boss. So our information is provided through various means, including our website, which you can see a screen grab of there, and also our intelligence. You can access that on the website, as well as our news and trade journals. I edit 3 of those trade journals. And across that journal portfolio, we cover a range of sectors, including non-wovens and engineered fabrics, technical textiles, dyeing and finishing technologies, digitalization or industry 4.0, industrial knitting technologies, and natural and man-made fibres. And believe it or not, our first magazine to be published, International Dyer, dates back to 1880. So we have a very long history in publishing. And we also publish several trade show newspapers, including the daily show paper for ITMA, the Textile Machinery Exhibition, which I'm sure some of you will be aware of or may have even visited in the past. So last year our team spent a week in Barcelona producing the newspaper. And we did have various newspapers and trips planned for this year too, but unfortunately they've had to be postponed for obvious reasons. So we move to the next slide. Because we're very much a technology focused company and we've got plenty of experience when it comes to hosting our own events and webinars, after the COVID-19 outbreak hit, we decided to launch our own virtual trade show called Innovate Textile and Apparel, which will be held on the 15th to the 30th of October. And the aim of the event is to reconnect textile and apparel value chain by providing a platform pretty much like this one to showcase and present innovations. But this will mimic the style of a physical trade show by featuring virtual booths with chat options and video displays. And we're also going to feature conference sessions and seminars, as well as roundtables with industry experts debating some of the key topics in the industry. So it's something we're very much looking forward to, and we've had a lot of interest so far from companies who, like us, just want to resume some normality and drive business continuity. And now on the next slide, going back to our website, earlier this year, we introduced a new feature that I'd like to just briefly tell you about called WTIN Patents. And this is a comprehensive patent search and analysis tool specific to the textile and apparel industry that enables you to search over millions of patents across the last 15 years from the textiles field, including additive manufacturing technologies. And if we click again to the next slide after that, you can learn more about these features. So you can search for various patents and view the full bibliographic content right inside our website, including the supporting drawings. We also have an artificial intelligence tool that we call WTIN Discovery, and this provides analysis of a certain patent so that you can quickly understand the focus and content of the patent in a visually engaging way. And not only that, but patents are of course a great way of gaining insight into innovation and the direction that the industry is taking so that you can keep ahead of the latest trends and developments. So that was something we were really keen to introduce and something we've been asked about previously by our clients. And as you can imagine, a lot of the recently filed patents relate to things like personal respiratory protection, textiles and face masks and liquid repellent coatings, etc. So we use this sort of data to report on the direction of innovation. Now moving on to the next slide, before I discuss a couple of recent innovations I found interesting that I've reported on, I just wanted to touch on our intelligence channels. And so we have 5 in total. digital textiles, so primarily digital printing, Textile 4.0, which focuses on things like artificial intelligence and robotic manufacturing and software developments, performance textiles, which covers primarily active wear, protective textiles, which focuses on outdoor textile topics like water and insect repellents and antiviral protection, and smart textiles, which are generally defined as textiles that are able to sense or respond to changes in their environments, often made possible through the integration of electronics. And so through these intelligence channels, we delve further into a topic through our technical reports, innovation and company profiles to bring clarity and insights to industry developments and to help people monitor market trends, discover more about the key players in the market, as well as the academic research that is taking place in that sector. And through that, our overall goal is to help companies evaluate the competitive landscape and make informed business decisions. And I just included, I don't know if you can properly see the second one, but just a couple of quotes there from our clients. Now moving over to the next slide, and from within the smart textiles field, we're seeing an increasing focus being placed on remote health monitoring. And this was something that at the start of the pandemic was even more prevalent, as people often couldn't physically meet with their healthcare practitioners. And so what we're seeing is that smart textiles are facilitating a shift in healthcare away from a culture of treatment towards one of prevention and early intervention, as they're able to generate, collect, analyse or transmit health data through the use of sensor technology and actuators to provide caregivers with rapid diagnostic information that enables them to provide medical assessments. And in fact, I found this interesting. It is estimated that by using smart textiles for monitoring physiological signs, around 70% of all illnesses are preventable. So on the next slide is an example of such a product from the Canadian company Myant, and they launched its skin platform, they call it, a couple of years ago. And this is a digital intelligent interface that through textiles aims to provide a second skin, they call it, that can read, record, analyze and respond to users' needs. And so to do so, sensor technology is integrated into textiles such as underwear to gain holistic insight into their physical and mental state by allowing users to track daily activity, sleep and stress levels. So it pretty much works a bit like a Fitbit, but in textile form. And most importantly, by connecting this system to a smartphone, users can receive information and advice that enables them to actually make sense of that data so they can make changes to their lifestyle and physical fitness. And then just quickly on the next slide, I recently reported on a smart nappy or diaper, as we usually refer to it as, called Smarty, primarily aimed at the elderly, that can monitor critical health data using algorithms to remotely monitor health conditions and flag potential issues before they arise. So this helps to ease the burden on healthcare staff. And again, it's meeting that need for preventative care that continues to grow in importance. So that's one direction the industry is taking, and it'll be interesting to see what else comes from this, because I think as far as consumers are concerned, smart textiles are still very new and niche. And so the industry will really need to think of a way of promoting this, everyday use. And I think Myant's and Smarty's products will really help to do this. And so that's it from me. Thanks so much for listening. I really appreciate it. And I'll be prepared to answer some questions at the end for anyone who has any.
Great. Thank you, Fiona. That was lovely. I was so fascinated when I looked at your presentation when you sent it through about smart underwear and smart nappies. It's just brilliant. I never would have thought that would be possible, but we're kind of in the future now, aren't we? The question I had for you, I suppose, before we move on to the next speaker, is around that idea of smart products in the health world. I was thinking about the smart underwear and thinking, you know, how do we make sure that goes to the people that need it, as opposed to it being a sort of people that only rich people have to sort of, like, a bit like you mentioned the Fitbit. I think of people who've got Fitbits, but they're actually very fit themselves anyway. I'm thinking about the more elderly people or disabled people for whom that smart technology can really help flag up problems that they may be having. What have you got any thoughts?
Yeah, that's true, because a lot of a big burden, or a barrier, should I say, to these products so far has been the high cost of the sensor technology. And so I think, I mean, from speaking to people within this industry, I think what it's going to take is a big government push, and from healthcare providers to get these products into the mainstream, and into hospitals. And, you know, companies like Smarty, they're really helping to kind of start that push. But yeah, it's going to take a lot of, you know, as Parik was talking about, people working together, because especially in the smart textiles industry, it's renowned for being interdisciplinary, and so it is going to need that, and that's why it's a fascinating industry, but it's still very niche, and so we'll need to see a lot of collaboration, I think.
Yeah, that's a great point. Okay, well, so thank you, Fiona. If you want to stop your video, we'll come back to all of the stuff that you've been talking about a bit later on. And I would encourage you to, if you think of questions for Parik or Fiona, even while someone else is talking, do put them in the chat, and we'll have a proper Q&A later. And Natalie's made a really good point. Textiles blows my mind, but it certainly blows mine as well. Thank you. Just a quick message from Angie says, amazing, Fiona, completely new ideas for me. Well, same here. Okay, so we're going to hear from Sahar now. So if you want to start your video, Sahar, then if you can't do that, I shall. Oh, yeah, there you're here, and I'll ask you to unmute. Now, in a little while, we're going to hear from you, and I'll just bring up your presentation. Okay, so. Right, if you just bear with me, I shall share my screen again, and we'll do exactly the same thing, and just ask me to go on to the next slide, and it should be fairly straightforward from there. So over to you in a second once I've shared it.
Thank you very much, Tom.
Okay.
Hi everyone, and good afternoon. Thank you very much for all attending this meeting. Maybe we cannot live without the color and the arts that fashion has to offer to us, but we have also entered an era where sustainable fashion and responsible fashion comes into reality. And today I'm going to talk about the project that we are doing at the University of Leeds, and which is funded by Future Fashion Factory. And we hope to achieve some of the main goals for the sustainability of the fashion. So this project is called the Quantification and Communication of Fabric Tactile Properties. Can you please go to the next slide? I'm going to briefly talk about the tactile perception, the fabric tactile sensation, and the tactile properties, and the subjective and objective evaluation of fabric mechanical properties, the digital communication of fabric properties for customized textile manufacturers. And the next slide, please. Thank you. We rely on our 5 senses in order to communicate with the real world, and actually our 5 senses work as transducers in order to transmit the signals into our brain, where these signals are analyzed and interpreted, and gives us a mapping of the real world and the perception of the physical reality. One of our important senses is our tactile senses, which might be under the shadow of our visual and auditory senses. However, it plays a very important role, especially it gives us our bodily awareness, and maybe without our tactile sensation, we may not be able to do very simple things like holding a cup in our hands. Yes, and then next slide, please. Thank you. The tactile sensation, this project actually revolves around the tactile sensation. And there are 4 types of mechanoreceptors under the surface of the skin, and there are thermal and pain sensors under the skin. And there are different receptors. Each of them are specialized to react to different source of frequency exposures, like low frequencies, medium frequencies to high frequencies. And also the stimuli exposures can happen in short term or in long term, and each of the receptors are responsible for one type of the receptors. For example, the slowly adapting receptors can respond to static stimulation like form and roughness. Again, there is another type of slowly adapting receptors which responded to the stretch, but it has got a larger receptive field, and helps us to actually perceive the response to a continued stimuli. And some of the other receptors also work towards a very high frequencies. For example, they can perceive this slipperiness. For example, if a glass is slipping from the hand, and they can analyze the high frequency vibrations. Yeah, next slide, please, Tom. Thank you. So the fabrics actually on our everyday basis, on our daily basis, we touch the fabrics, maybe unconsciously or subconsciously. We analyze them, and we see whether the fabrics are stiff, whether the fabrics are soft. So the handle of fabrics have been in the attention of retailers and fashion designers. And the hand feel of a fabric plays an important role in the success of a product, along with the appearance and the design of the final garment. For example, when someone goes to a shop and wants to investigate a fabric, at first, the first thing that they see, for example, they see the appearance of the garments, the color of it, but also the second thing that we want to analyze and investigate is how we understand the fabric. So it is the mechanical response of the investigation of the fabric, which is also which plays an important role into our shopping behavior. For example, does the fabric absorbs the energy? Does it reflect the heat of the hand? How flexible is the fabric? Does it take so much energy in order to shape the fabric? Does the fabric creases easily or not? So all of these features like softness, stiffness, sponginess, flexibility, all of these features are very important into perceiving the fabric. And but the reality is that each of us, although we have the same sensorial feelings, and the underlying mechanisms might be similar to each other, but these aesthetics may happen to be interpreted different from each of us. For example, some of us may perceive a fabric softer, some of us may perceive it less soft, and therefore we want rather to have an objective evaluation of the fabrics rather than just rely on the subjective evaluation of the fabric. And that is in our next slide. From a long time ago, I think about 20 years ago, there were scientists who wanted to objectively evaluate the fabric tactile properties. And one of the first machineries were Kawabata. In Leeds University, we use a LUFAS machine, Leeds University Fabric Hand Evaluation System, provides a novel approach for the quantification of fabric properties. Using LUFAS, we can imitate what people do when they evaluate the fabric. For example, they compress the fabric, they twist the fabric, and from there we take measurements like sponginess, crispiness of the fabrics and have these values quantified. And we later use these data to analyze the fabrics, for example, to predict fabric properties using manufacturer data. Next slide, please, Tom. Actually, this slide shows that the measurements that we take from LUFAS, like smoothness, crispiness, flexibility, we later want to be able to communicate these features with the audience without the need of physical real interaction. So we rely on immersive technologies in order to communicate these fabric properties, and some of the examples of the haptic technologies are in the next slide. Haptic technology is probably one of the coolest immersive technologies that is available at the moment, and we wanted to use the UltraLip device in order to communicate fabric properties in immersive technologies. And haptic technologies in the picture in the left bottom corner, we had some events, and we had some showed this device to people to simulate the smoothness of the surface of the fabric, whether the surface of the fabric is rough or smooth to the touch. So this device works with ultrasound, and it focuses collection of waves to the mid-air, where the ultrasound can be perceived by the hands. Actually, it vibrates the air underneath the skin of the hand and generates a sensation to the skin by using the ultrasound. The next slide, please. And we want to enable customized digital manufacturing future fashion supply chain. The importance of fabric touch field have encouraged fabric scientists to quantify the fabric tactile properties objectively. And we want to use LUFAS as a key role for quantifying and communicating the fabric tactile properties. And this project has the potential to transform online shopping, where customers could virtually feel fabrics without physical interaction with the fabrics. Imagining a world that the cycle of returns and postage of products and garments is reduced by providing the immersive technologies for households and people that can touch the fabrics and have a feeling of the garments without physical interaction. I think this will take a large, heavy burden from the industry and also from the environment, because it can potentially reduce the sending of the fabrics, the garment, and the returning of the postage. And thank you so much, everyone, for listening to my presentation.
Thank you, Sahar. That was
Thank you.
brilliant. That's so fascinating, isn't it? I mean, if anyone hasn't heard the phrase haptic technology before, that's the thing that you should remember from your presentation, just this idea that you can digitally feel things. I mean, it's just incredible. As Sarah put it in the chat, we're talking about how communicating how a fabric feels, but digitally, this is amazing. I mean, I completely agree. Now, we can talk a little bit more about this later on.
Sure.
How, I mean, again, it sort of goes back to that user experience. I'm very aware that I'm reluctant to shop online, or I have been, because I can't see, or clothes in particular, you can't feel the fabric. You can see it, but you can't feel it. You don't know what kind of, is it going to be comfortable to wear? So having this technology available, how soon do you think that might happen? Is it a matter of decades before we have it in every home? I mean, that's kind of a hard question, I know.
I think that the game industry, actually, many people have gaming immersive technologies at their houses, and I think it is possible that this can be available to people. About the device, for example, the haptic technology, I think that this technology might be expensive at the moment, but I think in the future, and with more users using it, the price on that will reduce in time.
But it's just great to see that we're at the forefront in this area, internationally, let alone nationally. It's wonderful. So thank you so much for that presentation.
Thank you so much.
I can imagine that a lot of people will be wanting to talk to you about this, like Fiona's presentation and Parik. So if you're sitting there going, "Oh, I'd love to know more about that," please store up your thoughts and maybe put them in the chat. And after the next presentation, we're going to have more of a conversation with it. We're trying to bring more people into this conversation. Now, we've already got a couple of chat messages, but I'm going to move on now. Thank you, Saha. And I'd like David. Could you? There we are. Here we are. There's David, and I'll ask you to unmute. There we go. So, David, we're going to hear from you now. You're connected in with Saha's project. I'm very aware that you're working on similar things. So, you'll explain about this. I'll just share the screen so we can see your presentation. So, of course, Saha's working at the University of Leeds, and David's in the industry. He works at Roches, as you'll see from the screen there. So, David, I'm going to spotlight you, and we're going to go from there. So, David, over to you.
Hi, well, good afternoon, everybody, and thank you, Tom, and thank you for the organisers and the invitation. As I've said before, my name is David Buxton, and I'm the Sales Director at Roches International. We are an international company manufacturing high-performance textile performance testing equipment, dyeing and finish equipment, and parts and servicing for the textile industry. Following on from the excellent presentation from Saha, it's great having the research and the development, but it's not the only piece of the jigsaw in the Kirklees textile innovation cycle. Research and innovation in itself and in isolation is fantastic, but as I said, in isolation it only remains a great piece of work. But what happens to the research? Nothing. Does it just get put in a drawer or part of somebody's PhD? We feel that some of these items, some of this research needs to be brought out and more made of it. So there should and must be a process of assessing the options to make this research in innovative technology a commercial product. Tom, can you change the slide, please? And the next one, please. I'm sorry, I've missed one. Okay. So getting back to the presentation from Saha, Leeds Uni have a great research into digitizing the feel of a fabric. They have working prototypes, they have software that's proving points and making databases. They even have a number of very high profile retailers and sector leaders who are showing a lot of interest in this technology. So are all the pieces of the innovation cycle in place? Well, no, of course not, because we need somebody now to be able to take the research of Saha and the team at Leeds. They need to take that to make it a commercial product. And they need different expertise to make this happen. Tom, could you do a slide, please? And this is where really the Kirklees and the West Yorkshire sector is proving very, very fruitful. They are benefiting greatly from the synergy between academia and industry. So Roches was actually approached by Leeds University to become part of the development team for the fabric handle tester. So having you all been amazed at Saha's presentation, I'm now going to give you even more amazing to say that this is going to be a commercial product. So we were asked to become part of the team, but what does it mean to become commercial? We are a business of selling things. That's what Roches International does. It makes things and sells things. So if we make something, then we have to be able to prove that there is a market for it. We have to prove that it's affordable, it's robust, it doesn't break at the slightest touch, and especially with this particular project, we must ensure that the results that we get are consistent with a proper testing piece of equipment. Could you do the slide? Thank you. Excuse me. So, does this sound relatively simple? Well, it sounds simple to say. However, there are significant challenges to manufacture a machine that is effectively doesn't exist at the moment. We have to make the machine, as I've said, it has to be robust. It has to be aesthetically pleasing. It has to be able to be sat in front of a customer, and you must be able to defend your item, your machine, to the customer to make the sale. So how do you come, how difficult is this? Well, if I asked all of you to draw a picture of a car, I suspect all of you will draw much of a similar type of design because there is a precedent to how the car looks. However, the difficulty comes if there is no precedence to how it looks. How do you draw something you've never seen? It's never been made. How do you start the process of this? And this is something that Roches has had to deal with over the last months. Designing a machine around a series of functions. As you'll see a little bit later, I think we've done this extremely well. Another one of this serious challenges that we come across on this particular project, the sample preparation when the research is being carried out was carried out by trained technicians, and it actually is very, very labor intensive and very, very difficult to achieve. But for a commercial item, we had to ensure that the sample preparation was not labor intensive. It had to be done automatically. It had to be accurate and consistent throughout every single test that we carried out. The same parameters must be achieved at the end of the sample preparation. And to this, there's been a number of very innovative engineering solutions to solve this problem. Some of the parameters that we had to get across, we have differential fabric tension. We have the precise location of the fabric on the mounting device. We have to measure a twist action, a pull action, a compression action, a recovery action, and frictional forces on the same machine and on the same sample preparation. So as you can imagine, the complexities of this, of being able to achieve this, are quite immense. As well as the manufacturing side of making a machine, there is also the software that we have to consider. This is making a database from Leeds Uni into a commercially acceptable product. Software for the machine is very time consuming and very, very complicated. And both of these avenues, both manufacturing and software, must run in tandem to ensure complete and utter compatibility. For this particular product, there must be not only just the machine carrying out a test, it has to be able to report the test in a meaningful manner with meaningful results. Could you slide, please. Yes. Okay. So, as you can see from this slide, with the aid of modern manufacturing techniques such as CAD/CAM, 3D printing, laser cutting, we're able to generate a drawing relatively quickly, and we're able to manufacture 3D printed parts that allow fast understanding on whether the concept that we're trying to put together actually works or not. As you see, the picture that you're seeing on the slide there is a small cutout rendition of part of the machine. Okay, if you can just do the slide again, Tom, please. Okay, this slide, everyone, this is now 3 different views of the machine of which we are now in the process of manufacturing. You can see in the center there is what we call the load station. That is where the sample fits and all the action happens, all the twisting and the pulling and the compression and all the actual testing. And as you can see from the center and the right picture, the sample protection the sliding front panel. We feel that not only does the machine do a very, very interesting job as Sahar has presented, we think the machine looks absolutely and utterly fantastic. If you can just change the slide, Tom, please. This particular picture here is the actual machine. This is a physical, tangible product now. This is what we have in our office, and it's nearing completion now. So everything that Sahar has explained very, very technically and very well is now put into practice in a single machine. Sorry, except the haptic technology. We don't have the air technology as yet, but this is going to measure and report all the other aspects that Sahar very eloquently presented. We think this particular machine has got such amazing possibilities in the open market, not only in the supply chain for reducing time and carbon footprints in sample transportations around the world, but I think Tom's already mentioned into the market of the digital retailer. There are a number of people at the moment who are producing software that have what's the word I'm looking at? They have a model of the fabric, and it sort of moves when the model moves. But imagine what would happen if we can integrate this data into these companies and show the actual fabric moving as it should in real life, because the data and the algorithms that this is measuring, we believe, will allow us to measure fabric on here and give the data to these companies to input and have fabric behaving as it would in the real world, which is just an unbelievable concept. So just to bring it to a close, if you just want to step on a slide, Tom, please. So as a marketing, this is what we're actually going to be starting to do very shortly. We are going to be exhibiting this with the retailers and brands. We have to look at developing tests and databases to prove what happens with all the different fabrics and things. And of course, we will be showing it to the global textile exhibitions. Clearly not this year, but hopefully next year we'll be there, and we'll be having this front and center in our shopping basket. So this is really what you're getting with the synergy between academia and industry within the Kirklees and West Yorkshire area. We believe we have a fantastic opportunity to move innovation, to research innovation to a commercial product in many, many areas. And this is one that I think everybody should be very proud of. So thank you very much for your time, ladies and gentlemen, and obviously we'll take questions at a later point. Thank you again.
Well, thank you, David. I think it's fascinating to see how a product or an idea can start within research and academia, then move its way through into industry and actually have an effect on all of our lives. And as Nat says in the chat, well, she asked the question. Actually, guys, would you like to come back and and we can see everybody on the screen. Well, not everybody, but like the speakers, if that's all right. So Sahar, Fiona and Parik. And I'll just ask this question to anyone who wants to answer it, and that's, how much is this product or these products that we're talking about being marketed and used for international industrial sales to reduce air pollution in terms of flights? You briefly mentioned that, David, but is there a focus on how this can actually save carbon footprints for companies? Is that something that you're really focusing on?
Is that, do you want to, is that for me?
David, yeah.
Well, yeah, of course. Within the supply chain, currently there's a lot of, if you like, coming and going. You'll have the designer in a particular country finds a piece of fabric that they like. They will design a garment around that piece of fabric, and then send a sample of that fabric somewhere overseas to their within their supply chain, who will then make a piece of make a fabric according to the specifications. And when they've got the specifications that they believe are correct, the handle is correct, because at the moment all you can do is touch it with your hands. They will send the fabric back and say, hey guys, how's about this? And the designer will say immediately, I'm sorry, that's not quite soft enough, or that's too hard, or that's too crisp, or whatever, and say, can you do it again? So that's come all the way from the UK to the supplier. It's gone all the way from the supplier back to the UK, and then it's going to go all the way from the UK back to the supplier for a correction. With this, this will be like a color measurement. You will measure a piece of fabric in the UK. You will send the data points to your customer, with your supplier and your supply chain, who will then have the necessary data to measure their samples against using this machine. If they get parameters within a plus minus, then the fabric is deemed to be of the correct performance. Therefore, you have saved not only the carbon footprint, you've saved a week, 2 weeks, 3 weeks on production time as well.